can start our class, inshallah.
Has started.
Okay, great. So we started the evolutionary algorithms, and we are discussing the common, common aspects of these techniques. And I think we covered all this selection process, roulette wheel selection and tournament selection. And I think we also covered this slide, which gives you the flow chart of the computational flow of the evolutionary algorithms. As we mentioned, we initialize the population randomly within the search space between the range of each parameter. We select randomly the value of the parameter, and then we go to the fitness or objective function, and we evaluate, and then we have 10 solutions or 100 solutions or 50 solutions, depends on the population size that you select or you set earlier. And then these solutions will be, you select parents, and then you do crossover, and you do some operators here over the parents, and you end up with the children. And then you go back and evaluate the children, and you get the fitness of each one, and then you select parents out of them, and then you can recombine and do crossover and whatever operations here. And as I mentioned earlier, these two operations here, these two operations are different from one technique to another. So that distinguish each technique is how to generate new generation out of the old generation. This is the old generation started here. This is the initial, and this is the old. Let us say it old generation. And then when we do offspring crossover mutation, we end up with the new population here. New population. And this new population will go to this. How to generate the new population? This is different from one technique to another. Okay. So genetic algorithms, we, as mentioned, we have binary coded and we have real coded. It depends on your problem. But anyway, you can, of course, you can use binary coded, even if your problem has real optimized parameters, you can encode them in zeros and one, and you can decode them later on, and so on. Nasser Hakami, please, do you have a question, Nasser?
Yes, Doctor.
Yes, Doctor. Yeah, please.
I am confused between in the wheel selections. We are selecting our criteria for the fitness. It's not necessary always what's giving the maximum or the minimum, for example, but based on our criteria. But for the second one, for the tournament, we said we compete between two solutions. But again, are we selecting the same fitness criteria, for example, or we are looking always to the final solution?
In roulette wheel, fitness function or objective function or the performance index you define will not change here or there. Is it clear? And you are not,
Doctor, you mean that the fitness criteria, it is the same like the objective functions, or it is additional selecting criteria to get the best answer for the objective function?
You can consider it as an objective function. The objective function. This is the fitness. اوكي الاوبجكتيف فانكشن هي الفتنس. بس يعني here you have to be careful. Maybe the fitness means the one is with the bigger value. Okay, is it clear? But
Okay.
here in minimization problem, يعني if we have for example okay, I need just some space to write something, or I can insert. No problem. Okay. So assume that you have 5 solutions. This is the solution. This is the number, and this is the fitness. The fitness here is the objective function. This is the solution number 1, number 2, number 3, number 4, 5, and so on. Assume this is the minimization problem. This is a minimization problem. That means the fittest one is the one with the lowest objective function. You are searching to minimize. So the one that gives you minimum value, this is the fittest solution, or this is the best solution. For example, if the solution number 1, you have an objective function f of x equal to x square, مثلا, for example, or whatever. This is gives you 4, this gives you 2, this gives you minus, طبعا مش ممكن تكون minus لأنها x square. But this could be 0, this could be 1, this could be 10. So which one is the fittest one here? Which one is the fittest?
Third solution, yeah.
This one.
Yes.
All right. This is the fittest one. Is it clear?
Yeah. So meaning the difference between the first criteria and the second one, that we are selecting as a group for the fittest, and the second one we are competing one by one.
Yes, exactly. But here, let me clarify this point. Then we have here very important point. You excited. Here, for the tournament selection, you select two solutions randomly. And maybe we select 1 and 5. And then we compare between 1 and 5. Which one is the fitter one? Which one? One.
First one.
The first one.
Yeah.
So the first one, solution number 1, will be considered as a parent. And then we will go back to the population here, and we select other 2 randomly. Maybe 1 and 2, مثلا, for example. Maybe it's random. Maybe 2 and 3 or whatever. 1 and 2, we compare the fitness. Which one is the fitter one? Number 2. So this is the first parent, and the number 2 is the second parent. So these 2 parents will be taken for crossover and mutation, for further processing. So these are the parents now. And we expect from these 2 parents 2 offspring, 2 other solutions. Okay? Okay. And this will be repeated. And this action will be repeated. Again, you go and select 2 parents or 2 solutions, you select the fitter one. طبعا, as I mentioned, you can select the fitter one based on a probability also. Am I right?
Yes. Yeah, now clear.
Here it's okay. انما if you implement this here, لا, it will be different here. Here, the probability, we need here the higher probability will be for the fitter solution. Am I right?
Yes.
So if you divide here this f0 over the summation, it becomes u0. So the probability of selecting this one, which is the fittest one, am I right? It becomes 0. So we have here conflicting, some kind of conflicting. And the one here with the lower values will have lower probability. which is not our target. Our target is to find the higher probability for the fitter solutions, for the fittest solution. If you implement this directly, the objective function here directly over this formula, the one with low fitness or objective function will give you lower probability. وبالتالي this is will conflict our target. So you have to do some extra work here, and one step more in order to convert this, the minimum to be maximum. And you can مثلا say إنه this fi will be considered here will be 1 over the objective function. 1 over the objective function. Assume this is 1/2 and this is 1/4. This will give you higher probability than this if you substitute here. 1/10, this is the worst one. So this will be the lower probability here. So if you apply this roulette wheel selection, you have to be careful around this. You have to do extra work to reflect the strict sense of the word fitness. Is it clear?
Yes,
I
and
hope
again,
I address your
yeah, we'll do the same with the tournament, that we will select a two parent to come with the new solutions from this, the best two fitness, for example.
For roulette wheel?
No, also yes, for roulette wheels. When we are getting the two most high.
Yeah, the procedure is the same.
Okay.
Procedure is the same. You select here one, select two randomly, and you get one, the first parent, and select two randomly again, and then you select the better one. So this is the second parent. Here you will do the same.
Yeah,
but I wanted to address this point. And if it is minimization problem, you need to convert the objective function to fitness. And you may need to divide 1 over the fitness. Okay, 1 over the fitness.
Yeah. Okay.
No.
Thank you.
طبعا this is of course you have to have some idea about your problem in order to know what is the range of the objective functions that you have and so on, so you can do this wisely. Any question?
Yes, please.
Yes, go ahead. Raise your hand and then I know who is talking. Khalid Sulaiman Jibreen?
Yes, Doctor. Sorry.
Go ahead, no problem.
Is it okay to convert the problem to maximization problem and invert the fitness function, just make it with a minus sign?
Yes, you can. Of course you can.
Okay.
Of course you can flip between minimization and the maximization by multiplying the objective function by minus sign. But again, usually you develop, without loss of generality, you develop the code for minimization, for example. And if you need maximization, you can flip the objective function. Or you can develop the code for maximization. And then you can play with the objective function to convert it to minimization. But this is easily can be done. But again, the concept of fitness here should be observed. If you use the objective function directly, and this is the minimization, this minimization problem here will not be right to substitute directly with the objective function here. You have to convert it to 1 over the objective function or whatever in order to this. Of course, if 1 over 0, you can put a condition if the value is 0, then you have 1 or higher value, bigger value. So you can all these can be done. And this is the flow chart. We started already genetic algorithm, binary coded or real coded. And definitely we have covered also this one and this one, gene, chromosome, population, and all this. We start, I think we stopped here last time. طيب the basic genetic algorithm.
Doctor?
Yes, please.
Just a quick question here regarding the evolutionary process, evolutionary logarithm process. Now I can see that at the beginning we are initializing a population of individual solution randomly.
Yes.
And then I didn't get the idea on how to select the let's say part of the solution, and based on what we select some of the solution and regenerate the process again.
لا انت you generate the initial population which is randomly generated. Do you agree with this?
Yes.
يعني for example if you have مثلا f of x equal to x square and you have x between -5 and 5, you can generate, for example, let us set here the population size, let us set the population size equal to 10. يعني each generation will have 10 solution population size. So in this case you need to generate 10 solutions within this range. So you satisfy the condition, and at the same time you generate randomly this value. Therefore I equal to 1 to 10, x equal to x minimum plus r times x max minus x minimum. And this will be repeated for 10 times. Okay?
Okay.
So you generate 10 solutions between x minimum and x maximum. R is a random number, uniformly distributed between 0 and 1. Is it clear, Fawzan?
Yes. Yes.
Then you go with these 10 solutions and you substitute here. X square, and so on, x1, x2, x3, all these 10 values you substitute. So this is the evaluation of the fitness function. Now you have 10 solutions here. You have x1, x2, up to x10. Okay?
Yes.
Here select subpopulation for offspring production. يعني select the parents. We need to select 2 parents in order to do crossover, do mutation, and generate new children.
Okay.
You can select here 2 randomly. وليكن solution number 1 and solution number 9. What is the objective function of corresponding to this one? What is the objective function corresponding to this one? Which one is the better one? You need minimization or maximization? Whatever. And you can select the better one. Okay?
Okay.
So this is the first parent. And you repeat this to select the second parent. 2 randomly and get one of them. So these are 2 parents. You have here 2 parents. Out of this, you have 2 parents.
Out of 10, we have 2 parents.
This is for the first time. And you will repeat this 5 times again.
Yeah, 5 times.
Yani these are 2 parents to bring to obtain 2 children. And we will repeat this process 5 times.
Yeah.
And each time we will produce 2 children. So we have to keep the population size is the same. We have to keep the population size is the same. Yani this process will repeat it 5 times. And each time we will get 2 parents. And to get 2 parents, you need to do this tournament selection twice. Did you get the point? And I will come from top to bottom.
Yes.
If you want to, is it clear? The procedure is clear?
Yes.
Yeah, this will be repeated here 5 times to get 10 parents. And these two parents, you do crossover and mutation, then you have two children out of these two parents. And you repeat this, and you have here another for loop. This for I would say 1 to 5. This will repeat it 5 times. Select two parents, do crossover, do mutation, you end up with two children. Let us take these two children to the new population. We fill the new population now by two children. And then we will repeat this. Two parents, two crossover mutation, we have another two children. So we fill the new population by additional two children. This will be repeated 5 times to get 10 solutions in the new population. And then you will say, yes, please.
هو الquestion هنا okay first let's say we choose x1 and x9
Now,
okay, and then we do all the steps here and we repeat it 5 times. When we repeat the second step, second iteration here, we go and select from x1 to x10 again.
لا ما انت خلاص انت here you have completely new solutions. ما خلاص مش هيقعد بقى ان we don't have now x1 x2 x3. When you do crossover between x1 and x2 and you do mutation, now we have a different solution completely. So we are not going to x1 and x2 now. يعني we will replace two parents اللي هم x1 و x9 but two new solutions by two new solutions again completely new completely solutions. يعني you can say x11 and x12 مثلا. These are not randomly selected from here. This comes from the crossover and the mutation. New completely solution. Okay? Is it clear?
Yes.
خلاص يعني هو x1 والx2 this was the initial population selected randomly. But after crossover and the mutation we have two children which is not يعني created by the parents now. We are not going to x1 and x10 again. For the second iteration, for this loop. When you come here, we have to new population completely, and then you can do selection and crossover and mutation. But when with this for loop, for this for loop, yes, you are selecting from this x1 up to x10 to generate other 10 solutions, other 10 children. Okay? I hope you know.
Yeah, that's my question. That's my question. For I equal 1 to 5, I select every time from x1
Yes.
up to x10.
This is what you have. And you don't have new solutions. And you are creating new solutions. And this is the population that you are selecting from at the beginning. Okay? But later, when you have new population,
Yes.
when you have new population, this new population will come here and then it becomes old population. And this one, when it comes here, will becomes old population. And you select from this old population 10 solutions, 10 parents, and you process this here. Is it clear?
Yes.
Clear? طيب الحسن. الحسن.
Yes, doctor. When you're choosing the parents, supposedly X1 and X9, based on what do you determine if they need maximization or minimization?
لا ده minimization maximization you have to specify it from the beginning. يعني انت what is your objective? You have a problem and you want to do what? يعني this is maybe the earlier stage. You know and your problem is minimization or maximization before starting.
So it's based on the objective function.
This is the problem dependent. يعني انت if you want to minimize, if you are interested in cost, so you need to minimize the cost. If you have losses, you need to minimize the losses. Profit, you need to maximize the profit. reliability مثلا, you need to maximize the reliability. So the objective function, this is a problem dependent. From the beginning, you know that this is a minimization problem. Okay? Or maximization.
Okay, thank you.
Okay. Nasser Hakami again.
Yes, doctor.
Yes.
When we are creating the Newton solutions, the children's, for example, the first two select from X1 and X9 to create X11, X12.
Yes.
The second two children, the X13 and 14, can I select X1 and X5, or I cannot use it anymore before the old parent?
No, you can use it.
So I can use a new combination from the old parent even if it is used once before?
Yes.
Okay.
You can select X1 and X5.
Okay.
If X1 is a good solution, this will be repeated several times. And it will be selected several times.
And then when after complete the 12 children, then we delete the old 10 parent.
لا انت you come here and you up to X20.
Yes.
Up to X20. When you reach X20, this becomes the new population.
Yeah, this one.
And
Okay.
you forget about the old population, خلاص. The old population completely now out of order. So we are now processing over this new population. And we calculate the crossover, we come here. This for termination criteria. If stopped, otherwise you can go and evaluate for each X11, X12, X20, you calculate the fitness value. And then you select the parents again from those solutions. You do this 5 times to create X21 up to X30. So this is the new population now, and so on.
Okay.
Is it clear?
Yes, clear. Thank you, doctor.
Okay. These are the advantage of GA over the classical, and these are some of the terms that we use. Now, start with a large population of randomly generated attempted or solutions, individuals to a problem. So this is the first step. Repeatedly do the following. يعني was simply the flow chart that we have there. This flow chart with general flow chart for all the evolutionary computation. So the genetic algorithm is the same. We start with randomly, and then we evaluate the solutions by getting the fitness function of each one. And then we keep the subset of the solution, the best one. Later we will see about the elitism. And here, just to give you an idea about the elitism, maybe you have here good solutions at the beginning, and you don't want to lose these good solutions. Maybe you select them here and you do crossover and mutation. Maybe the children are not better than the parents. ممكن ولا مش ممكن؟ ممكن يكون البيرنتس are not as good as the parents. فانت you don't want to lose the good solutions. So you can say, okay, and I will rank those solutions, and I will take the best 2 solutions right away to the new population. I will copy them directly to the new population. I will not do any crossover on this or mutation on this individuals. And at least you have here 2 good solutions in the new population. Okay, this is called elitism. And you select the elite solutions and you copy them directly to the new population. If you select 2 here, you will repeat this one just 4 times, not 5 times. Is it clear? So you generate 8 children with those 2 parents. This will represent the new population here. So this is the elitism that we can implement here in order to avoid losing the good solutions. Yani, at least we have good solutions in the new population. And the crossover or mutation, they can destroy the solution, as we will see when we implement them here. So this is the, again, we need to move forward. So you can evaluate, you can keep a subset, 2 solutions, 10% of the population. You can keep them directly, you can copy them directly to the new population. Use these solutions to generate new population and quit when we have satisfactory solution or you run out of time. Yani, this is the stopping criteria. If you reach to the maximum generation, you have to, at the beginning, you can say no generation maximum equal to مثلا 100. So you will do 100 iteration of the genetic algorithm. So if you reach 100, then you can stop, or you can, if you have satisfactory solution. يعني مثلا if you, for example, if you want to reduce the cost مثلا, and you reach to a threshold that is acceptable. If the cost goes below يعني up to the 10 مثلا whatever, then you can stop. For example, distance مثلا, if you have a distance and you need to minimize the distance, if the solution becomes, or the fitness becomes 0, خلاص, you can stop. يعني you will not find the distance less than 0. So you can stop here. So no need to continue until 100 generation. But if you have satisfactory solution, then you can stop the search. So this is, we will discuss in details the stopping criteria later on, inshallah. So we create a population of individuals, and as we mentioned, we will consider at the beginning we consider the binary coded in order to clarify the operators and so on, and then later we will see the real coded genetic algorithm. So binary coded, يعني all the chromosome, this is a chromosome 1, chromosome 2, chromosome 3, أو الكروموسوم هو solution, and this solution 1, solution 2, solution 3. And this chromosome consists of several genes, اللي هي parameter, الجينز اللي هي optimized parameters, as we mentioned earlier. Maybe the parameter will be represented by 4 bits here. So this is parameter 1, this is the parameter 2, this is parameter 3, this is parameter 4 and 5 and 6 and so on. So these are genes, and this is a chromosome solution. So assume this is the first solution, this is the second solution, this is the third solution, and you can fill the population here. So definitely when you calculate the fitness, you will find some of them good, some of them bad, and so on. So these are the coded chromosomes. The chromosomes are character strings analogous to 4 base chromosomes in our own DNA. Our chromosomes have like 23 pairs of genes or 46 genes. يعني اللي هم body الchromosome has 46 genes. Okay, so this is the way that we have. Then these individuals follow a process of evolution, and the crossover and the mutation operators are processed by manipulation at the coding bit level. يعني here we will explain this in details later on. So this is the chromosomes, and assume that when we have this objective function, And this is an example of the optimization problem. Assume that when we have maximization, we need maximization to x squared, where x varies between 0 and 31. If this is binary code, if x equal to 0, how to represent it? If x equal to 31, how to represent it? For this representation, how many bits do we need in order to represent this x? How many bits? 5 bits?
Yes.
Why 5 bits, Abdullah?
Because we need 5 bits because of 31.
31 is represented in binary as, right? This is 1, this is 2, this is 4, this is 8, this is 16. So if the binary is, here is 1, 1, 1, 1, 1, 5 bits, you get 31. So this 31 will be represented by 5 bits. If you have, مثلا, if you, of course, here between 0 and 31, you will generate several solutions. So assume that when we have 1, 0, 1, 0, 0, how much this value in real? This is binary. How much? This one represents 4.
20.
This one represents 16. So this is equivalent to 20. Okay? So when you have here several solutions between 0 and 1, you will find the solutions as 1, 1, 1, 1, 1, 0, 0, and so on. So you have 1, 1, 0, 1, 1, 1, 0, 0, 0, 0, 1, 0, 1, 0, 1. These are the chromosomes here. Right, we need to maximize this value, x squared. Between 0 and 31, we mentioned that you need 5 bits. You need 5 bits to represent this parameter, this optimized parameter. And we have here, how many genes do we have in our problem? How many genes?
32.
How many genes?
5.
5 genes. We have here 5 genes. 5 genes. Now we have 5 bits. But how many genes? What is the definition of gene? What is the definition of gene? What is gene?
Parameter to be optimized.
How many parameters do we need to optimize here? How many parameters do we need to optimize here?
32.
X squared.
One only.
1.
Only one parameter.
Only one parameter, which is x. Which is x? We are searching for the value of x that maximize x squared. So this is optimized parameter. This is optimized parameter. We have only one gene in this problem. We have only one gene. One optimized parameter. If we have, for example, we say this is x squared plus y squared, and y also varies between 0 and 31 or whatever the range of y. In this case, we have 2 optimized values here. So we have 2 genes. Okay? And in this case, if we have x squared and y squared, and this x and y between 0 and 31, x will be represented by 5, and y will be represented by 5 also. So the chromosome now will contain 10 bits. This is for x and similar for y. 1, 0, 0, 1, 0, whatever. Okay? Is it clear, ya shabab? I hope this will be, we are running very slow, or we are moving very slow in order to understand the concepts. Then once you understand the concepts here for genetic algorithm for one of the evolutionary computation, For the others, it will be just just you are reading, you understand everything. So here for this maximize x square where 0 x between 0 and 31, you need 5 bits. So, and we have here only 1G. Okay. Type, okay. So can we create, for example, what do you think the population, how much is the population size here? How much the population size? Abdullah, Barayan?
I think 2 to the power 5, right?
This is the population size?
Yeah.
31.
كم؟
31 دكتور.
ايه هو البوبوليشن سايز؟ يا عبد الله.
Possible solutions.
البوسيبل سوليوشنز لا، ما هو البوبوليشن سايز البوسيبل سوليوشن within the population. يعني انت at the beginning you will say ان انا I will take 5 solutions.
No, I mean the whole solutions يعني. Available solutions. The whole available solution. This is the population.
لا, this is not the population size. We mean the population size and how many solutions will be considered at each generation. And this is arbitrarily set. يعني مش من هنا من البروبلم هنقول ان البوبوليشن سايز 5 ولا 10 ولا 31 or 32 whatever. No, the population size is arbitrarily parameter. This is a key parameter for the genetic algorithm. You have to set it by yourself. You can say, no, and I will use 6 solutions. And that example that we just discussed before, we have 10 solutions, x1 up to x10. So we have 10 population size. We can increase, we can have 20 solutions as a population size, and so on. And you can arbitrarily set the population size. It has nothing to do with this. لأنه if assume that this is a real coded genetic algorithm. Real coded, يعني x is not integer. X is not integer value. X is a real number. So how much of the population size, if this is the case, between 0 and 31? It is infinity. If x is real, right? So the population size gives you, this is arbitrarily set. You say, no, I will take 10 solutions randomly at the beginning, and I will keep each generation, I have 10 solutions, 10 solutions, and we generate 10 children, and then and so on. So you can select this arbitrarily. Okay, encode solutions, just use 5 bits, 1 and 0. Generate initial population. Generate initial population, as we mentioned here. You can generate initial populations as you want. How many initial population you can set? For example, we have here 4 initial population, 4 solutions here. This is the initial population. I would like to remove this to make it a little bit clearer. So you have here population size equal what here? Population size here. If this is our population size equal to 4. Here, population size.
And that 4 is selected arbitrarily.
Arbitrarily, randomly. Okay, yani you have here 5 bits. You have here 5 bits. What you will do, you will generate a random number. And you will select this, if this random number greater than 0.5, this bit will be 1. Otherwise, it will be 0. So you go to this bit and you generate a random number and you apply this. and another random number, and you apply this. Another random number, you created 0.7, so it becomes 1. 0.2, random number, then it becomes 0. 0.6, 0.7, 0.8, 0.1, and so on. 0.01, 0.00. And you create this randomly between zeros and 1. So if this is zeros and 1, then you can say, no, this is 1 and this is 4, يبقى دي 5 and this is 8, يبقى this is represented 13, x equal to 13. For this one, you have 8 and 16, يبقى 24. X here equal to 8. X here equal to 1 plus 2, يبقى 3, plus 16 equal to 19. So this is equal to x. And then you can take these random solutions here generated and you substitute in the objective function to calculate the fitness. So for 13, x square, 24 square, 8 square, 19 square. So you get the fitness of each solution. So this is the next step. This generated randomly, initial population, and then we evaluate each solution against the objective. So you will find out, these are the strengths and these are the fitness. Okay. This was 13, so it becomes 124, 8, and 19. These are the fitness value. Type for the selection. Keep in your mind that this is maximization. For tournament selection, which is the easiest way, the tournament selection, you select two solutions randomly. Assume that we select A and C. Which one you will choose for the first parent?
A.
A. Then randomly again you select another two solutions to find out the second parent. Assume that you select B and C. So which one?
B.
B. A and B are the parents. So we will select them as the parents and then we will see how to do crossover and mutation over these values, A and B. So we have these two parents. We will see how to implement the crossover and mutation later on. So this is if the tournament selection. You compare directly with the fitness value. This is maximization, so the higher value, the better solution. If you want to implement the roulette wheel, if you want to implement the roulette wheel selection instead of tournament selection, so you will add all these fitness together and you divide 169 over the summation. And now maximization for directly will be, it's okay. But if it is minimization, in this case, as we pointed out before, you have to do some 1 over f or whatever. 576, so, and these are the probabilities now. These are the probabilities for each one. So you can say, this is 14.4, and this is the 49.2. So you can say, we have here A, and between 0 and 14.4, or طبعا you divide by 100, and you generate a random number between 0 and 1, so this becomes 144. And then you have B. You sum them up here, so this becomes 63.6. So you have here 0.636, and then you have C, which is 5.5. If you add here 5.5, which is 0.055, على الكلام ده يبقى 0.655 was 36. So it becomes a 91, so 691. And this one, it becomes طبعا of course 2 up to 1. So this is solution D. So you have here 1. So if you want to implement the tournament, the roulette wheel, so you come and generate a random number and you select a random number there between 0 and 0.14. You select A between 1.4 and 63. You select B between this value and this value. You select C between this value and 1. You select D. So this is the first variant. And again, you generate another random number and you select the solution here related to the certain value. Is it clear? Am I clear in this? Whether it is tournament selection or roulette wheel selection?
Yeah.
Do you have any question?
Yes, clear, Doctor.
طيب سالم غانم, please.
Yes, Professor. Just regarding the random variable generation, is there any significance in the probabilistic distribution we select from, whether it's uniform, this normal distribution, or whatever?
This, all the random number that we want to generate is a uniform solution, uniform distribution. Uniform distribution يعني ايه؟ يعني random number with equal probability between 0 and 1. Between 0 and 1 with equal probability. Okay? And we don't go to normal distribution or Gaussian distribution. Is it clear? Now this is we are not addressing this distribution here. When we create a random number, it should be, and we are not biased around any value. Okay, we don't have مثلا, for example, the average value and we want to be within around the average value. We are not doing this. When we create a random number, this random number is a uniform distribution, not normal, not Gaussian distribution. Is it clear?
Okay, Professor.
طيب هشام محمد, your question يا هشام.
Yes, Doctor. Can we say that the tournament technique is more efficient than the other?
لا, well, it's not more efficient. Well, it is easy to implement than the other. لأنه look, here you are addressing directly the fitness value. You are taking this directly with the tournament selection. You don't need to go and check calculate the probability and do this division, and this will be repeated, by the way. And if we have new solutions, we have to calculate again the probability, and we have to do this, and generate. We have to do this every generation. And here, the fitness is clear. And when we say this is a maximization problem, when I ask you what is the fittest solution here, you will just directly say no, 5576 directly, without any further computation. For example, if it is minimization problem, which one is the fittest here? This one will be the fittest. If it is minimization problem, and it gives you the minimum objective function. Tournament selection easy to implement. Which one will give you better? No, there is no difference. And at the end you select it randomly with the uniform distribution. There is no. I hope you know this addresses your question. Khalid Sulaiman.
Yes, Doctor. Thank you. Now, we chose A and B as parents using tournament selection. In this case, I have to choose other three parents, right?
This will be this other three parents. Why? Why three?
Shouldn't we make 4 sets of solutions?
لا, يعني A و B will produce two children. Right?
Yes.
This will produce two children. Am I right?
Yes.
So what you need is to repeat this process once again, just once, to create another two parents, like A and B, for example, and this will create you two children again. So in this case, we have 4 children, so we fill the population. The population size here is 4, and should be kept 4 for each generation. But
Okay, now.
Okay,
Yes,
go ahead.
please.
Yeah.
Now, if for the roulette wheel, do I have to do the same? I have to choose 4 solutions. I have. What I mean is, if I'm using roulette wheel, still my population is 4, and I have to choose 4.
Yes.
So I suppose I chose B. I
Okay.
generated a random number, and it came in the range of B.
Okay.
I still have to, yes, I still have to do this 3 times to
Oh,
get.
yes.
Okay.
Yes.
After that, the crossover and mutation will start after
Yes.
this process.
Exactly.
Okay.
What you can do, okay, you can do it. We have here two two approaches. And here for this flow chart, what you can do as I give you here, and we have a for loop to select 2 parents, and then these 2 parents will go to the crossover and the mutation, and then you will repeat this again and again until you fill the population. Okay, this is one approach. Second approach, as you pointed out here, you can select the parents here directly, all the parents, and then you do crossover for all, and then you do mutation for all. Yeah, for all, I mean what I mean by for all. And you select this is the first parent, second parent, third parent, fourth parent, and so on. And then when you come to here for the crossover, you select these 2 parents all together. 3 and 4 will be combined together. 5 and 6 will be combined together, and so on. So, and then you go to the mutation later. And you do this crossover and the mutation as a batch. Selection as a batch. You select the batch, the complete batch. Okay? And then you do crossover for all. This is one approach. Second approach, as I mentioned, you can do 2 parents only, and then you do crossover, do mutation, and then you come back and then select 2 parents and so on. But this is one approach, and this is the other approach to do this. Yes, you can select the 4 solutions right away at the beginning. So you have parent 1, 2, 3, 4, and then you can take 1 and 2, and then 3 and 4 of each other. Is it clear?
Yes, Doctor, it is. Thank you very much.
Okay. Fine. So evaluate each solution against objective, and this is the evaluation. And then you can see here the solutions. Let us say, assume that we have this solution selected randomly 0, 1, 0, 0. So that means you have this here 8, and this 8 becomes objective 64. And you have another solution. This is called the chromosome, and this is the fitness value. The chromosome and the fitness value is called the individual. This is the individual solution. The value, the optimized parameters, and also its fitness, associated fitness. The pair chromosome fitness represents an individual. So X and its objective, an objective value, this represents. The fitness plays the role of environment and establishes the basis for selection, and you select based on the objective function. Assume that we have another individual. This is the solution. This is the chromosome here, 0, 0, 1, 1, 1. So this is 1, 2, 4, 7. So its fitness is 49. So these are 2 chromosomes selected randomly, for example. Is it clear? Right. Now we will see the selection process, crossover, mutation, and elitism concept of the genetic algorithm. Selection, already we discussed either roulette wheel or crossover or tournament selection. And as we mentioned, in a tournament selection is much easier to implementation. You don't need to process or to do extra computation for the objective function in order to convert it to fitness if it is minimization. Selection is a process in which a new generation of population is formed by selecting the fittest individuals in the current population. This is easy to understand. Selection creates a new population by selecting individuals from the old population biased toward the best. طبعا definitely احنا we compare and then we take the best. So we are biased with the good solutions. Tournament selection, as we mentioned, we choose two individuals at random, like this solution, for example, 0, 1, 0, 0, 1, which is 9, the objective is 81, and this one, for example, which is 3, and the objective is 9 here. The best wins with the fixed probability. You can say, as we mentioned, we pointed out for this before, and you can directly you can select the fittest solution. This is the first parent, خلاص, directly. This is the first parent. Since the objective here is higher than this, we are maximization, but this is best. So can, but as I mentioned earlier, we need to enrich. Maybe, for example, this bit, for example, here is 1. This bit here is 0. So allow for bad solutions to survive for maybe 1 generation, 2 generations, and they will disappear definitely. But you can allow for this also to survive or to beat this one, but with very low probability. And this will win with high probability. This may win with very low probability. As I mentioned, we can set here the 80% مثلا, probability of 80%, we will choose right away the best solution. So within 20%, this could win the tournament. Just to make your search robust. Keep in your mind, and this is very important, keep in your mind that you are targeting the global solution. So it will not harm if you have very bad solution in the generation. This will not affect the good solutions or the best solution. But this will may have some characteristics which can by crossover and mutation can improve the population. Okay, so this is 1, 9, and this is this will win, of course, by about 80. Generally, the most fit wins. However, with 80% time, however, but sometimes it is just the opposite that happens. This one could, beat this one, although it is the worst solution, but you may select it with very low probability. So this is the selection, and this is the tournament selection, and you can repeat this again and again until you fill the population. Is it clear? Okay. طيب now crossover. The crossover is recombination. And you have here 1, 1, 0, 0, 1, and you have another, this is parent 1. And parent 2 is selected also as 1, 0, 0, 1, 0. So what is a crossover? A crossover, you recombine these. One way to do this, you can say, no, okay, let us cut here and shuffle this. 1, 0 will go here and 0, 1 will come here. So we do some recombination of the genes of the chromosome. Let us cut at this point, and then we can, replace, and you can shuffle these bits among the two parents. So this will give you here, this will be 1, 1, 0, and this will come here, it becomes 1, 0. And this one, for example, will be again 1, 0, 0. This will be kept as it is. And then you combine this here, it becomes 0, 1. So now you have two children out of these two parents. Okay? So as you can see here, and this is probably clear here, this one, this child now is better than any of the parents. Am I right? This one is 18, 16, 8, يبقى 24, 1 يبقى ده 25. This one is 16, 8, 2, it becomes 26. So this will give you better value over the parents. This one could be lower than the parents. And you have now, you create two children which are different than the parents. The crossover could give you good solutions and also at the same time can give you bad solutions. Both ways. And for example, if you have 1, 1, 0, 0, 0, 0, 0, 0, 1, 1. For example, if you cut here, and you shuffle this 2 zeros here, at the end you have very bad solution. Worst solution you can ever see in this problem. The crossover will do some kind of changing the structure of the solution. Hopefully, this would, enhance the search capability. You have good solutions, and you may have better solutions, best or worse solutions, and both ways. So this is the crossover. Crossover is the most dominant, operator in genetic algorithm. Most dominant, it happens with very high probability. Sometimes it is not necessarily to do crossover. You can say, no, I will do crossover with 0.9 probability. So at each time, these are the two parents. I will create a random number. If this random number below 90, I will do crossover over these two parents. If this random number is greater than 0.9, which is most likely not the case with low probability, if it is greater than 0.9, I will not do crossover, and I will copy these two parents directly to the new population. I will not do crossover. Is it clear? A crossover, you may or may not do it over the parents. It is high probability, yes, most likely will be done, but sometimes you copy directly the parents to the, you consider the parents as the children without any change. Okay? It is responsible for producing new offsprings by selecting two strings and exchange portions of their structures. The crossover is explorative And here it is 25, and this one was like then when you do crossover, then you go to 26. You explore other areas of the search space. So you move forward to other areas in the search space. So it is explorative. It makes a big jump to an area somewhere in between two parents areas. So you do this is the new offsprings may replace the weaker individuals in the population. Here, what you can do is, طبعا يعني I don't want to talk much about the we have several approaches and dozens of approaches to run this evolutionary computation. As we mentioned, these are the two parents. You can do crossover, and then these are the two children, and then you go take these two children together to the new population. Sometimes you said, no, I will not take these two children right away. I will compare these two children. This is 26, and this is worse than this. So I will take 26 with the best solution here. So I will not take the children, but I will take the parents, and I will compare between the children and the parents. Maybe the children are better, will be taken. One children, one parent will be considered as a new population, or yani, a lot of variants of the operations here. So the new offspring may replace the weaker individuals in the population, or you can use them directly to the new population. Okay, so two parents produce two offsprings. There is a chance that the chromosome of the two parents are copied unmodified. Yani you copy the parents directly to as offspring, as a children. As I mentioned, with 0.9, you can generate a random number. If R is greater than 0.9, no crossover. If R less than 0.9, then you do crossover. No crossover means what? And you consider the parents as the children without doing a crossover. I hope things are clear and you are following. There is a chance that the chromosomes of the two parents are randomly recombined, crossover to form offsprings. The chromosomes of the two parents are randomly recombined. طبعا of course we mentioned we have 1 1 0 0 1 0 0 1 0 1. You can cut here, but also you can cut here. You can cut here. You can cut here. And it is not necessarily to have a specific location. In order to do this, you can generate a random number, integer random number between 1 and 4. Either one, you will cut here. If this random number comes to 3, then you cut here. Comes to 4, then you cut here, and you change only these two portions. And you can have this, crossover point. This is crossover point. This crossover point is chosen randomly. You create, as I mentioned, integer random number, and then you can see where you want to cut and change the portions of the solutions. Generally, the chance of crossover is between 0.6 to 1. You can set the crossover probability. This 0.9, this is called the crossover probability, B crossover. Between 0.6 to 1. 1 يعني you will do crossover whatever. 0.6 يعني 60 times 60% you will do crossover, and 40% you will copy the parents directly to the new population without crossover. So usually we set the crossover probability between 0.6 and 1. You have to run several times this techniques. You try 0.6, you try 0.7, you try 0.8, and then each time you observe the optimal solution, and then you can see which one gives you the best solution you consider it. So this is the way it is done. Any question you have? Nasser Hakami, please.
Yes, doctor.
Yes.
Can we do, rather than just swapping the values, make, for example, from one parent, just go directly to the children by making the, for example, AND gate, XOR, or NOR, any function that it can change the value between 0 to 1 and 1 to 0, since all is binary. Or we can make combination between two parent by AND gate or OR gate to get a new solution.
لا يعني no need to have AND gate or so. لأنه AND gate this becomes 0, this becomes 0, this becomes 0, this becomes 0. Okay. No need to say no. We have different actually. We have different approaches for the crossover. How to do it? I mentioned here, and you can cut here and change the portion. This is one way to do it. The other way is to do some kind of uniform crossover. Let us generate a random number, either 0 or 1. Okay? You can generate a random number, either 0 or 1.
Okay.
And you can say, no, let us say, if it is 0, I will pick the value from here. If it is 1, I will pick the value from here to create the children. So, for example, if the first, for the first bit, you have it 1, so you will take 0. Second bit, you generate a random number, 0 or 1, it becomes 0, so you will take this one, which is 1. The other one is 0, so you'll take this one. And the other, then you take 0, this one. And you create 0, 1, and you select between this, whatever, this is 1. So this could be another approach for the crossover. This will be discussed later in details. And I just give you what is the concept of the crossover at the beginning. But later we can see the variants of the crossover. Okay?
How can I ensure that I'm not trapped in the same area? For example, if I have possible solution, for example, 1,000, and then I started by 5 population or 10, and then just to move to another area where it has a better solution, maybe I still trapped in the first 20 solution or 50, while the best solution in the last group of the 1,000. So
here the problem that's called the premature convergence. This is a common problem in such techniques, premature convergence.
What does it mean?
What does it mean? It means at some time, maybe after 5, 10 generations, you will find all the children are the same. Just a copy from each other. And when you do crossover, it gives you the same children. Am I right?
Yes.
So you end up with all the solutions are the same, typical solutions. In this case, يعني خلاص يعني what you do crossover, you do mutation, you do something here and there, nothing is moving. If you reach to this level of premature convergence, in this case you can disturb the population. you can say no, oh, all of these are the same typical solution. Let us inject 2-3 random solutions as we did in the initial population. يعني هبدأ from scratch. مثلا 50% of these solutions will be compensated with the random selected solution. زي ما عملنا في الفيرست ستيب. At the first step. And you do some kind of disturbance to the population if you reach to this.
Okay. Yes.
Okay.
Now it may bring another solution since we changed the original population itself.
Exactly. Yes.
Yeah,
Exactly.
thank you.
Okay. طيب. I think the time is over. Let us stop here and continue next class, inshallah. If you have any question, stay with us to discuss. Otherwise, you can leave. Okay.